Hey everyone, we're moving on to 7.4, the last section in chapter 7 that we'll cover. It's another type of hypothesis test. This one's for population proportions, so no means, no standard deviations, all percentages. The steps will look pretty familiar. The one thing, or the few things that are new, the verification step, we'll have to verify these little formulas are true. That kind of is similar to 6.3 when we were doing confidence intervals. And then we got a new formula, so we'll have to use that. But notice it's a z, so we're still going to use that standard normal distribution. So once you get the z, then steps 4, 5, and 6, they're all the same as 7.2. So there's nothing new there, which is nice. So let's give it a try, and we'll run through the steps and see how it goes. First thing we need to do is write down the HO and HA. We got a claim, and that's obviously an HA because it does not have equality. And then HO will just be the opposite. This is a left-tailed test because of the less than on the HA. And that's our step 1. For step 2, that's when we do that verification. So let's focus on this NP greater than or equal to 5. Right. So we're just checking that is true. Now n is given as 200. That's the sample size. And p we're going to use from the hypotheses. So that's the hypothesized p. So I'm taking 200 times 0.34. And I'm calculating that. I'm getting 68, which is bigger than 5. We're good. Okay. And then the Q is just the opposite of P, right? So Q is 0.66. Right? Remember, if you want to do that over here, Q is just always 1 minus P. Right? So that's where we're getting the 0.66. That's my decimal. Okay, and that's even more. That's 132, so that's definitely bigger than 5. So that's it. Verification is just checking those. That looks like a sigma. Let's redo that, make it look a little nicer. Okay. So oftentimes you can do that step without really writing anything down. You're just you can eye it. And then if either of those fall below 5, you stop. You cannot run the hypothesis test. Whoever did the research needs to go back and get more people. Okay. The next step is getting that z. Right? And that's that formula above. It's p hat minus p. Oops. P hat minus p, right? Remember the difference between those two? P hat is the sample proportion, whereas p is the population or hypothesized population proportion. Okay? And then the denominator has pq, no hats, divided by n. Okay, so we do have to calculate the p hat real quick. So I can do that over here. P hat. Remember that formula from chapter 6 is x divided by n? So I'm just taking 65 divided by 200. Just turning that 65 into a proportion. And that's, I'm getting 0.325. Okay. And that's what I'll use. Okay, so p hat 0.325. For p, I'm plugging in from the hypotheses. That's the 0.34. It appears there again, the 0.34. And then the q, we found that as 0.66. And then the n is 200. And that's what I'm calculating. Now, when you calculate this with your calculator, really make sure to put parentheses around that numerator. Make sure your calculator does the order of operations correct. Also, all those numbers underneath the radical in the bottom, make sure they're inside the radical when you do it in your calculator. So I would definitely try that in your calculator to make sure you're getting the right answer, but it should come out to be negative 0.45 approximately. Now I need to turn that into a p-value. So I'm going to go to my StatCrunch for that. And at this stage of the game, this is nothing new, right? Once you get that z, then steps 4, 5, and 6 are the exact same as 7.2 when we were doing z. So this is really just a review at this point. Remember how to get the z. Hopefully my StatCrunch loads. It's going a little slow today. And so you're going into the normal calculator, right? So click on the normal calculator, there it goes. So that's under Stat, Calculators, Normal. And then this is a left-tail test, so I'm going to go less than, and then I put in my z right there, negative 0.45, and compute. And there's my p-value, 0.3264. I can go back to my handout, and I got my p. P is 0.3264. And everyone knows what to do with that. You compare it to the alpha. So alpha in this case is 0.05, right, from this problem right there. Right? And though this is obviously greater than 0.05, which is your alpha. And when p is larger than alpha, we know what to do. When p is larger, fail to reject h sub 0. Okay, and you know what to do with that conclusion. HA is the claim from right there, and fail to reject HO. So fail to reject is always insufficient. And when HA is the claim, we use the word support. So that's my shorthand for the sentence, there is insufficient evidence to support the claim. And there you have it. Now, another option is you can run this all at once in StatCrunch because there's that StatCrunch feature. We've done the one for the t-test, but StatCrunch has them all. So if I go back to my main page, if you click on Stat, if you go down below Calculators, you'll see Z-Stat, T-Stat, and Proportion Stats. So Z-Stats you can use for 7.2, T-Stats you can use for 7.3, Proportion Stats you can use for 7.4. If I click on Proportion Stats, I'm choosing one sample with summary. The number of successes is the X. So in this problem, that's 65. The number of observations is the N. In this problem, that's 200. I'm performing a hypothesis test for proportion, and the proportion that we are using is 0.34. I just copy that from what we wrote down. And then the HA, that symbol was a less than symbol. I always like to show that critical value because you never know what my math lab wants. So that will be the setup for this. That's it. And then I hit compute, and I should get a similar answer, not an exact same answer. So what does it give me? It gives me the z-stat. Yeah, that's what we got, negative 0.45. We got that critical value. That's in case my lab asks for a critical value. And then we also get the p-value, 0.3271. Now we got 0.3264 because we rounded our z and then found the p. Here, so this one's a little more precise because they don't round the z. So 0.3271 is more precise. Now my math lab should accept both of those answers. It'll take it if you round the z to 2 decimals first and then find the p, or if you do it all at once in StatCrunch, it should accept that answer too. So there's some different approaches that you can take. Okay, back to the handout. Let's try another one. Well, heading on to this problem. Research Center claims that less than 50% of U.S. adults have access to the internet. Okay, so claim less than 50%. So I know how to write that. That's P less than 0.5. That would make HO P greater than or equal to 0.5, but the claim in this problem is HA. Again, we have another left-tailed test because HA is less than. Verification, you can verify that yourself. Let's jump right to the Z. The Z, we're doing P hat. Okay, notice this one, it gives us the P hat because it gives us the sample proportion, so I don't have to calculate it. I know the P hat is 0.39. And then the P is from the hypotheses, and then the p again from the hypotheses. If p is 0.5, so is q, and n is the sample size, 100 adults. So there would be the setup, and this works out to be negative 2.2. Make sure to put parentheses there. You'll want to verify that with your calculator to make sure it's giving you the correct answer. Okay, then I can go to my StatCrunch, get the p. So I can go to my normal calculator for the p. Stat calculator normal. It's less than negative 2.2. Negative 2.2. Compute. And I get my p-value of 0.0139. Okay, back to the handout. P is 0.0139. That is less than alpha, right? Alpha again is 0.05 right there. Right? So when p is less than alpha, that is reject h sub 0. Right? And final conclusion, we reject h sub 0. HA is the claim. So this one would be sufficient to support. Or at this level of significance, there is sufficient evidence to support the claim. The claim specifically that the proportion is less than 50%. Try the StatCrunch way too if you want to do the whole thing in StatCrunch. You can give that a go if you'd like. Okay, let's try one more. The research center claims that 25%. Okay, this looks like an equals, doesn't it? So here P is equal to 25%. And then HA is P not equal to. So here the HA, the HO is the claim. Let's jump right to find, oh, this is a two-tailed test. Let's jump right to my Z, where P hat. So do we have a P hat? Oh yeah. There it is, 21%. So again, they gave it to us as a decimal. That was kind of them. So I would put in 0.21. Right? And then my P 0.25. That's the top. Denominator 0.25 times the Q. Well, if P is 0.25, then Q is 0.75 divided by the N, sample of 200. And I can calculate that to get my Z. And I type this in, I'm getting negative 1.31. Okay, I can convert that to a P. There's lots of P's, isn't there? So the hypotheses are lowercase p, the p-value is an uppercase P. So that's the distinction if you get confused with all the P's floating around here. Okay, so let's go back to my table. Now this is a two-tailed test, so I've got to go with between. And then I put in my z-scores, negative 1.31 and positive 1.31, and compute. All right, so that generates two-tail. Now notice here, it's going to give me the red area. Well, I want the opposite of that. I want the tails, but I know how to fix that. That would just be 1 minus 0.8098, right? Which would be 1902. Okay, so I can jot that down. P is equal to 0.1902. Okay. So you gotta be a little bit careful with two-tailed tests because of the way StatCrunch works. It gives you that area between when you actually want the tails. So you gotta make that adjustment. And now it's all the same to make our conclusion. this is bigger than the alpha, right? Alpha is 0.10 right there. And when P is larger, it's always fail to reject. HO. And HO is the claim. We just couldn't reject the claim. So insufficient to reject. There's insufficient evidence to reject the claim. That's that one. Now, if you want to do it all at once in StatCrunch, I'll do one more of those to show it. So I would go back to normal page, open up a blank StatCrunch. That's when you can go to stat, proportion stats, one sample with summary. And then this one, it did not give you the X. It gave you the N is 200. But notice it gave you the percentage of those that replied yes, 21%. So you actually have to calculate what is 21% of 200. So you can do 0.21 times 200, 42. So you got to be a little bit careful with that piece. Sometimes they give you the X explicitly in the problem. Other times you're going to have to find it if they give you the percentage. And then hypothesis test, we're just going to make it look like how we wrote it down. Yeah, 0.25 is what we put there and not equal. Right. Can always show a critical value, good habit. And then that's it. Let's see what we get. So here we got 0.1914. So again, a little off from what we calculated, but that's okay. Either way is good. Because the z-stat is actually negative 1.306, blah, 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 and we rounded it to negative 1.31. So that's why our p-value from before was a little different. But either way, you'll come up with the same conclusion because that p is bigger than the alpha, and that leads you to fail to reject HO, insufficient to reject, etc., etc. Okay, so you got that part as well. Okay, so that's a good stopping point. That's the p-value method for proportion hypothesis testing. In the next video, we'll finish up 7.4 with some rejection region methods, and then that'll complete chapter 7. Okay, hope all is well. Take care. Talk to you later.